Hello and welcome. In this video, we are going to be looking at the F-net as applied to objects that are connected. So we are looking at connected bodies that are moving along a horizontal direction. These connected bodies can move with a constant velocity or they can be accelerating. It is important that you are able to identify all the forces that are acting on the body and also be able to draw the free body diagram as applied to a particular object that is that is being stated or asked. So if you've got a situation that looks like this, you've got an object or connected bodies, one an object mass B and then another one of mass A, and then there's a force that is applied to cause the motion of the object. Then there's another force that is resistive or that is acting in the opposite direction. You need to be able to identify all the forces that can act on the object. So as it is given, we can actually see or we can work out or determine forces that are available. In this, on body B, we can tell that there are forces due to in the vertical plane as well. So there's the F normal, and there's also going to be the FG applied to that body. And then at body A, there's also going to be an F normal, and there's also going to be an FG acting on body A. This FG and that FG are not necessarily going to be the same, and neither will the FN nor that FN there be the same, for the simple reason the masses of objects A and B are not also necessarily going to be the same. The other thing that you need to be aware of is that because they are connected bodies, there is a force that is going to act on body A, which is also going to act on body B. In order for the objects to move in the one direction, there is a tension that acts on body A, and that tension is pulling in the direction of the applied force. So you would call that T. But at the same time, the body A pulls back body B, so there is a tension also that is applied by body A on B, acting in the opposite direction. So you will have T acting in two opposite directions. So it's important that you are aware of that. So these are all the forces that are acting on this object, and then you can actually now go ahead and calculate or draw the respective free body diagrams and then perform the relevant calculations. So now if we were to look at the free body diagrams at body A and then also the free body diagram acting on body B, you would have the following. So free body diagram on A, free body diagram of the forces acting on A. So you've got the object A, so this is the diagram of the object A. Then using your ruler again, you show all the forces that are acting. There is the F normal, label it, and that F normal is equal to the FG. You also have the tension that acts to the right, and you also have the resistive force, that frictional force, which is acting to the left. And so these are the forces that are acting on body A. And then the forces that are the free body diagram of the forces that are acting on body B. So the free body diagram on B. So you've got the object. So that's object. So this is object A, and this is object B. Right? So what are the forces that are acting there? The forces that are acting, you've got your applied force, and you also have acting in the away from the applied force, you've got the tension which acts in the opposite direction, and then you also have your Fn and then your Fg. Now when you have done that, you are now able to start applying or doing your calculations of Fnet. You've got to solve these in parts so that you can end up having a simultaneous equation, and then from the simultaneous equation you should then be able to work out the unknowns that may be asked. So in this case, on free body diagram A, what do we have? We've got your T. So we would have our T minus FF. So it's along the horizontal. So in this case, we are interested only along the horizontal because this object is moving along the horizontal. T minus FF is equal to the MA, the mass of object A. So mass of object A multiplied by the acceleration of that body. So this here is the equation that we're going to make use of. And then on free body diagram B, what you are going to also have, it's going to be FAP, that is the applied force, minus T is equal to the mass of body B multiplied by the acceleration. The acceleration is going to be the same. T is also going to be the same. The reason the acceleration is going to be the same is that the objects are connected, and therefore if there is an acceleration, that means both objects are going to be connected, are going to move together. Remember, the tension of the object is also going to be the same, because what you guys are going to be limited to, you are going to be limited to objects that are connected by inelastic, inextensible, or rigid string objects, or strings, or a rope or something that doesn't stretch, and so therefore the tension is just going to be the same in both those objects. All right, so having found that, you are now able to then perform your calculation, this here being your equation 1 and that being your equation number 2. So you would then solve these equations simultaneously to find any of the unknowns that may be asked. So if you have, for example, a question that is given and you're required to calculate any unknown, I'm just going to give you a quick example, e.g. So we're just going to, okay, let's say you are given something that looks like this, and then they say to you, okay, the mass of A is equal to 3 kgs, and then the mass of B is 5 kgs, and then you've got an applied force of 25 newtons that acts in that direction, and you also have a frictional force, let's say, of 6 newtons that acts in that direction. You are required to calculate the tension and the acceleration of the system. You are required to calculate the tension and the acceleration that acts in the system. What is the tension and acceleration of the system, right? So we now have, you have drawn the free, so obviously you would draw the free body diagram. So I will just copy that free body diagram, and around free body diagram A, controls X. Oops. Control Z. All right, so I'll just quickly redraw this here because I'm struggling a bit with the object. So now the free body diagram at A, the free body diagram is, I've got the object, and that object has got a tension, and there is also the FF of 6 newtons in that direction, and it's 3 kgs. It's got an FN, and it's got FG in that direction. And so yeah, so what we are going to, so the first equation that I have is going to be equal to T minus FF is equal to, this is a 3 kg mass, important, is equal to 3A. And then at the other scenario, at B, the free body diagram also looks something like that. That's the F app, which is 25 newtons to the right. And then I have the tension to the left. And then there's the Fn. And then there is the Fg downwards. And this is the 5 kg block. So F app minus T is equal to 5A. So with these two equations, I'll call this equation 1, and this is equation 2. I will then add or subtract the two so as to solve my unknown. So if I rearrange or rewrite these equations, so equation 1, T minus FF is equal to 3A, and then or better still, let's just substitute into this here, so that, so this T, I don't know the value of T, minus 6 is equal to 3A. Then I think it becomes a lot clearer. And then here I've got 25 minus T, 25 minus T is equal to 5A. I then work out, so that's my equation 1, and that's my equation 2. If I add equation 1 and 2, equation 1 plus equation 2, so I will have T minus 6 is equal to 3A, and then on the other side I will have plus 25. I'm just rearranging that, so it's plus 25 minus t, and then is equal to 5a. So if I add these two equations, all I'm just going to get now, I will just simply add equation 1 and equation 2. T plus minus t is equal to 0 t's, and then minus 6 plus 25 is the same as saying 25 minus 6. So this here is going to be equal to 19. So you put that into your calculator. Minus 6 plus 25, that is what you get. That's where you get your 19, right? So 19 is equal to the sum of these two, which is 8a. So when you work that out, you would say your 8a is equal to 19. Divide both sides by 8. You will get 19 divided by 8, right? And so what you're going to get is 2,375. So your A is equal to 2,375 meters per second squared. Now that you've found your A, you can then substitute for A. Then substitute for A in equation 1 or 2. It's up to you. So I just use equation 1. So I'll say T minus FF, or T minus 6, is equal to 3 times 2 times 2,375. And then, so what I'm going to get is T is equal to 6 plus 3 times 2,375. Just put that into my calculator, times 3, and then plus 6. And so what you're going to get is something like 13,125. So T is equal to 13,125. T is the force, so then the units are 13,125 newtons. So basically that is how you would be expected to calculate that. So remember, if there are forces that are acting at an angle required to be resolved, equally in this scenario you would need to resolve them and then determine in the direction in which the forces are acting. Remember, important to first have a look at the force diagram. After you've found the force diagram, be able to represent the free body diagram for each of the components of that, and then write your sub-equations for what is happening at each part, and then thereafter you solve them simultaneously. Thanks for watching. I hope it makes sense, and if you liked it or you've got comments to make, please add your comments, and like, subscribe, and share the video for the benefit of everybody else who can watch it. Thank you.